Hey everyone, here's another example from section 2.2 covering finding limits. We're going to try to find the limit of this function as h approaches 0. Now, the first thing we're going to do is we're going to plug in 0, but you're going to see something happen here. So as I plug in 0, that's going to give me square root of 14 times 0 plus 1 minus 1 outside of the square root over 0. I've got a problem. I cannot divide by 0. Anything divided by 0 is undefined. So that means that this function is actually undefined at 0, meaning there's a disconnect. It's not continuous at the point 0. It disconnects. So it may look like a function that you might have a function that looks like this or something, but there's a disconnect there, meaning there's not an actual point on the that's a part of this function for the x value of 0. So what do we have to do then? We can still evaluate this limit, but we can't evaluate the limit in this form. So at this point, whenever we have issues with plugging in our number and getting something undefined, we need to do something algebraically that will kind of shake this up and get it so that we're not dividing by h here. For this problem specifically, my thought process was, let me see if I can cancel the h. So I start with the function and I say, okay, can I cancel this h down here? Well, I want to cancel the square root on top so that I can actually do some canceling here. So I want to get rid of the square root. How would I get rid of the square root? Well, let's rationalize the numerator. So if I rationalize the numerator, I'm going to take it times square root of 14h plus 1. And instead of saying minus 1 for this, I'm going to say plus 1 out here. Over square root of 14h plus 1. And then plus 1. Now, I kind of got this little scrunched here, and I'm sorry for that. Remember, this plus 1 up on top is outside of the square root, just like this one is. So when I multiply these, remember we're going to FOIL this out. So we're going to take 14 square root of 14h plus 1 times the square root of 14h plus 1. That just gives, so we'll put equals 14h plus 1. We take square root of 14h plus 1 times positive 1, and that'll give plus square root of 14h plus 1. And when I take the negative 1 times this, it'll give minus square root of 14h plus 1. And I take the negative 1 times the 1, minus 1 on top. On the bottom then, that's going to give h square root of 14h plus 1 plus h times 1, which is h. Remember, just distribute to each term. So then we can actually do some canceling. So this is going to cancel with this, which leaves 14h plus 1 minus 1 over, what I can do on the bottom then is I want to factor out an h. So I'm going to leave this with h square root of 14h plus 1 plus 1 here. So I factored an h here, I canceled these terms here. So then from there, I'm going to kind of work sideways for just a second. That's going to give 14h, because the plus 1 and the minus 1 cancel out. I have that over h square root of 14h plus 1 here. The h's are going to cancel here, and that's going to leave me with 14 over square root of 14h plus 1 plus 1. Now what's pretty awesome about this is, if I look at this, if I plug 0 in for h, that's not going to give me anything that's undefined on the bottom. So let's do that. That'll be 14 over square root of 14 times 0 plus 1 plus 1, which is going to give, we've got 14 over, that'll be 0, so we just end up with square root of 1 plus 1, which is going to equal 14 over 1 plus 1, which then equals 14 over 2, which equals 7. So we were looking with this function, we were looking for the limit as h approaches 0 for this function. When we plug it in, we got something undefined, so then we need to do some algebra to rearrange this function into a different form. So this is the same function as this was. Once we got it into a different form, we needed to actually evaluate the limit. So we plugged in 0, and we worked it out to, as h approaches 0, this function is approaching 7.